Okay, cool. So now we are starting our discussion with vectors. That is the first topic for physics 1010. Then physics 1015 is going to be the second topic. The first one is going to be units, and we are going to do that. Okay. So whenever we're talking about vectors, how do we define vectors? Yes. What is a vector quantity? So Gift is saying a vector quantity is a physical quantity which has got both magnitude and direction. Okay, that's cool. Now you are giving me this definition to say a vector quantity is a physical quantity which has got both magnitude and direction. Whenever we're talking about magnitude, we are talking about the size. Okay. Now we are saying a vector is a physical quantity which has got both magnitude and direction. So if they ask you to find the vector, for example, you have a vector A, we are coming there. Then you just find that this vector is 30 newtons, maybe it's 30 newtons. Then you leave your answer there. This is wrong. Because we are saying that a vector is supposed to have the size, which is the magnitude, and the direction. So if you just present your vector to say it is just 30 newtons, that is not a vector. A vector is supposed to have the direction. It can be 30 newtons south, 30 newtons north. So this 30 newtons, it is the magnitude. So if we say a car, or let's say vector A, which is 30 meters south. So this is the magnitude and this is the direction. So a vector is always a vector. You are going to find a vector having the magnitude and the direction. So once you just represent your answer as the magnitude only, meaning that is a scalar and it's not a vector. You get my point, right? So who can define what a scalar is? What is a scalar quantity? Yes, Albert. Yes, Albert. Can you mute yourself? I don't know if it's your network. It's tripping. Okay. Thank you. Prudence, what is your contribution? Okay. And no direction. Okay. So Prudence and Albert, they're saying that a scalar quantity. This is a quantity which has got only magnitude, which has got only magnitude. So it has got no direction. Okay. So this is a physical quantity which has got only magnitude. We can say this is a physical quantity which has got magnitude but no direction. That is just the same. Now, give me 3 examples of vectors, or 4 examples. You can give me. Let's interact, guys. Yes, we have. I'm trying to pronounce this name. Is it Lino? Is it Takunzwa? Yes, Takunzwa. Axel, I want you to give me one, sir. Just give me one. Acceleration. Okay, thank you, sir. Acceleration. And then we have also Bupe, force. We also have Mwape, displacement. Then we have Kapeta. Kapeta. Give me the example of vectors. Acceleration is already there, Mama. What else do you have? Momentum. Okay. Okay. So now give me examples of the scalars. We need to have also four. Prudence. Prudence. Give me one example of scalars. I'm mentioning the people who are raising the hands. So if you also want to say something, you can just raise your hand. Yes, Mwape. Give me the example of a scalar. Time. Uh, Takunzwa. Length. You are saying length? Distance. Thank you, sir. What else? Albert? Velocity. Are you sure velocity? Are you sure velocity is an example of scalar quantity? Velocity is a vector quantity. Velocity is a vector quantity, then speed is a scalar quantity. Yes, Chabota. Okay, give me another example. Temperature. Okay, let's end there. There are a lot. Now, I want us to talk about this. Okay, especially velocity and speed. And speed. What's the difference between the velocity and speed? That is very, very important. Now, I'm going to have my velocity here versus speed. Whenever we're talking about velocity, guys, why are we saying velocity is the scalar is a vector quantity? If I say a car is moving at 20 kilometers per hour south, this is the velocity. We are giving the specific direction to say it is south or north. Okay, if we just say a car is traveling at 20 kilometers per hour, we are not mentioning about the what, the direction where the car is going, meaning that that is the speed. Does that make sense? Yes. So that's the difference which is there. So whenever we're talking about the velocity, that is the scalar, the vector quantity. Whenever we're talking about the speed, that is the scalar quantity. Now, I want us to talk more about, before we even go anyway, I want us to talk more about speed. I want us to talk more about distance and displacement. We know that the first difference which you can give yourself, you can say that this is a scalar and this is a vector. Okay? But what you have to understand is that whenever we're talking about the distance, let's say we have point A all the way to point B, then this is 30 meters. Then we also have point A all the way to point B. This is 30 meters. If the distance, if the direction is the same, let's say you are moving from point A all the way to point B, the distance in this case is 30 meters. Even here, the distance is 30 meters. As long as you are moving in the same direction, the distance and the displacement, they are the same. Okay? Now, let's say you move from point A all the way to point B, and then you continue from here all the way to point C. Let's say from point A all the way to B is 40 meters. From point B to C is 10 meters. What is the total distance? What is the total distance? What will be the distance covered? Hey guys, what will be the distance? 50 meters. The distance is going to be 50 meters. Okay. Then, if I ask you what is the displacement in this case, what will be your answer? What will be the displacement? 50 meters. Yes. The displacement is going to be also 50 meters because it is moving in the same direction. Now, let's say we change the direction. That's where now the difference comes in. Whenever we're talking about the displacement and the distance. Okay. So let's say you move from point A all the way to point B. Let me put this. Let me just say point A all the way to point B, and then you move again from point. You should be able to see the arrows. You move again from point B all the way to point. Let's say this is C. So from A to this is 50 meters. Then here let's say you have moved from B to C as in 20 meters. So what is the distance covered in this case? 70 meters. What is the displacement? Negative 30 meters. Okay. Where is negative 30 meters coming from, sir? Mhm. So why are you saying negative 30? It's supposed to be positive 30 meters. So that's the difference which is there. Whenever you change the direction, the displacement and the distance, they are going to be different. Now what we're trying to say is distance, why we didn't consider the direction, because it is a scalar quantity. We're not interested in the what? The direction. So we just get the total distance covered. The total distance covered, how far have you moved? So you have moved from A to B and then from B to C. So you need just to add. But whenever we're talking about the displacement, that is a vector quantity. A vector is a physical quantity which has got both magnitude and direction, and we have to follow the arrows. So the first arrow from A to B is going toward east, and that is going to be positive. Whenever it's going toward negative x-axis, or we say toward west, that is negative. So you add. So here we have added what is 50 plus 20, we have gotten a 70. Here to get a 30, we have said 50, since it's positive, it's going toward east. Then 20 is going to carry a negative because it's going toward west. Then the displacement is now 30. So the distance and displacement, they are the same. The difference comes in when you change the direction. That's all. Does that make sense? Yes. So now if they ask you, apart from, you have got a question, if they ask you to say apart from you knowing to say distance is a scalar, because if they ask you what is the difference between distance and its displacement, you're going to say distance is a scalar quantity, displacement is a vector quantity. But apart from that, these two things, they differ the moment when you change the direction. Once you change the direction, distance and the displacement, they're not going to be the same. But as long as you are moving in the same direction, these two things are the same. Yes, gift mumba. Exactly. Exactly, sir. So distance is always positive, and then displacement, it can either be negative or positive. For example, if we say you move from point A all the way to point B, and let's say this is 20 meters, and then you move from point B all the way to point C, and let's say this is 30 meters. Distance in this case is going to be what? If you have understood, what will be the distance? 50 meters. What will be the displacement? Negative 10 meters. So displacement can be negative, but distance can never be negative. Okay. So now we are not interested in scalars. That's why the topic is vectors. We are just introducing vectors. So you need to know these foundations. Now, what you need to know, guys, is you need to know how to add the vectors. So let's talk about the addition of vectors. Addition of vectors. And we have said the examples of some vectors we you gave me to say we have the displacement, meaning it can be in meters. We have velocity, we have the force, which can be in newtons, not so. So we have got what we call, just a minute, you can mute your mic. We have got what we call parallel vectors. How do you add parallel vectors? Parallel vectors. Whenever we're talking about parallel vectors, if you have vector A, okay, which is maybe 20 newtons, and then I have vector B, which is 30 newtons. So A plus B, the moment I add these two vectors, since they are going in the same direction, they are both carrying positive, not so. So I'm going to say this is going to be 20 newtons plus 30 newtons, which is going to be equal to 50 newtons. So once you have been given the parallel vectors, meaning these two vectors can either be going in the same direction or in opposite direction, and you know what parallel means. Okay, if these two vectors are going in the same direction, you just, in short, if you're talking about parallel vectors, you just add them. Okay, so if we have let's have different one. Let's say we have vector a 20, and then we have vector b, which is going in this direction. Let's say this vector is 10 newtons. So what would be a plus b? Come on, what would be a plus b?
Negative 10 Newton.
How is it going to be? It's going to be, this 20 is going to carry a positive, it's going toward the positive x-axis, plus this is going to be negative 10. Okay, negative 10 newtons. So our answer is going to be 10 newtons. Do you have questions? Do you have questions? Yes, please. Prudence.
No, sir.
What if they were going to, what if we are going to the negative direction?
Yes, we are going there. We are going there. So let's say we have two vectors which are going in toward west. Let's say this is vector m. Let's say a, which is 5 newtons, and then you have b, which is 3 newtons. So a plus b is going to be what? What will be our answer?
Negative 5 plus negative 3.
So which is going to give us negative 8 newtons. And we know that whenever we're talking about newtons, this is this force is a vector quantity. It can be negative or positive, not so? Yes. Now this is the same even if these two vectors are going in this direction. You do the same. You know that when it's going in this direction, it is positive. When it's going in this direction, it is negative, not so? So if you have got vector a, which is maybe 20 newtons, then you have b, which is 30 newtons. You just say 20 plus 30. If they're going in opposite direction, then you do the same. Now there's also what we call parallel vectors. How do you add parallel vectors? So whenever we're talking about parallel vectors, no, I'm talking about, we're from talking about parallel vectors, we need to talk about perpendicular. How do we add perpendicular vectors? Perpendicular. What does perpendicular mean? What's the meaning of perpendicular?
When they are straight, they meet at an angle of 90 degrees.
Exactly. So if I have a vector, let's say this is my vector, and also this is my vector. Let me just put it here. So I have this vector. Let's say this is vector M. So let's say this vector is 30 newtons. Okay. Let's have vector B. Let's say that this vector is 20 newtons. I can even put 40. It's okay. Now, to find A plus B, that is the same as the resultant, we need to add these two vectors. So this is the vector A and this is the vector B. So I have 30 newtons. I also have a 40 newtons. So to find A plus B, this is our A and this is our B. To find A plus B is the same as just getting the line from this point all the way to that point. And whenever we're talking about perpendicular, like the guy said, we're going to make is making 90 degrees. Okay, so this is more like our hypotenuse. So this is our resultant. The resultant is a result of A plus B. That is the resultant. Okay, so you can say that R is the same as A plus B. Now, to find the R, what are we going to do? We use what?
Pythagoras.
Pythagoras theorem. So it's going to be R is going to be equal to the square root of A squared plus B squared. Not so. So our R now, whenever we're talking about the vector, a vector is either you put it in modulus, or if this is a vector, you put it in modulus, or you put it like this. If you just leave it this, you are going to assume that this is the scalar quantity and it's not a vector. Okay?
Yes, sir.
So a vector is always having the modulus, or you can just present it with what? You can present it with what? The arrow on top. Okay? So this is going to be, do you have calculators? So you have A, which is 30 squared plus 40 squared. What would be the answer?
50 newtons.
Sorry, what answer are you getting? 30 squared plus 40 squared,
It's 50 newtons.
50 newtons. Thank you. So 50 newtons, that is our resultant. Now we are just finding the addition, but we are going to come where you'll be able to find the direction as well, which is very, very important. Like we have found the resultant, we need also to find the direction, but we'll come there. So that is what we call perpendicular vectors. So whenever you have been given perpendicular vectors, this is what you need to do. Okay? Then you're going to be given another scenario. This is the common one. This is just the introduction, but the common one which you are going to find even in your test 1, in your quizzes, in your final exams, is neither perpendicular nor parallel. Okay? There's what we call neither perpendicular nor parallel. What does it mean? What does it mean when you say neither perpendicular nor parallel? We were talking about the parallel vectors. Maybe the vectors are going the same direction or opposite direction. Then the perpendicular vectors where they are making or they are making 90 degrees. Now neither perpendicular nor parallel is neither perpendicular nor parallel. So a vector can be like this. Let's say we have a vector. This is our vector. Now let's say this is vector A. Have you seen what is happening? So this vector is not in x direction, at the same time it's not in y direction, but it's moving in both x and y, not so. If we can have our xy plane here, we can see that this vector is going like this. So it is moving in both x and y. You get my point, eh? Once you have this vector is going to have the x component and the y component. So the x component of that vector is what we are going to call ax. The y component of that vector is what we are going to call ay. So this vector is going to be at an angle. That angle is what we are going to call the theta. Before we continue, are we okay?
Yes, sir.
It's going to have,
Okay. Yes, sir.
okay, we're going to have what we call the components. So these components, for us to use, we are going to use what we call SOHCAHTOA. So using SOHCAHTOA, we can be able, initially, you are going to be given this A, and you need to find the AX and AY, also how to find the angle. So using SOHCAHTOA, how can we find the AY and the AX? We know that SOHCAHTOA, this is 90. So sine is opposite over hypotenuse. So this is our opposite, this is our adjacent, this is our hypotenuse. So sine theta is going to be equal to what? The opposite is AY, the hypotenuse is A. Our goal is to find AY. So we'll cross multiply, we'll find that AY is going to be equal to vector A sine theta. Does that make sense? So whenever I'm trying to resolve
Yes.
any vector into y component, what I have to do is I need to get that vector sine the angle, then that is my my y component. So we have found one, ay to be equal to a sine theta. Let's go to cos. What will be cos theta? What will be cos theta? Cos theta is equal to
Theta
adjacent ax
over
over
over A.
over a. We want to find ax, so it's going to be ax will be equal to a cos theta. Now guys, whenever you are trying to resolve any vector, whenever you are trying to resolve any vector into x component, you need to get that vector cos the theta. That's all. Now how do we find the angle? How do we find the angle? We use tan, not so. We use tan, not so. So what would be tan theta? Yes, what would be tan theta?
AY over AX.
Tan theta will be equal to ay over ax. So to find the theta is the same as I divide it with tan. It's going to be theta is going to be equal to tan inverse ay over ax. But there are sometimes you might be confused. You might be confused to say, why are we saying it is tan inverse? It's coming from here, guys. If I have tan, theta has to be equal to ay over ax. If I divide both sides by tan, I divide both sides, it's the same as here I'm going to have tan. Okay, I'm going to remain with theta is equal to, if I have, this is the same as I have 1 over tan, then also times ay over ax. Now what is happening here is 1 over tan is the same as 1 to the power negative 1, not so. So that's where it's coming from. That's why we are saying that it's tan inverse ay over ax. So whenever we're trying to find the angle, we are going to be using this. Tan inverse the y component divided by the x component. As simple as that. Now, let's say we have vector A, which is 30 meters at an angle of 30 degrees. Let me put 40. At an angle of 40 degrees. How do we find the x component? find the x component and the y component. How do we find it? So what would be the y component? If I want to find the x component, what would be the formula? We are from talking about it.
AX is equal to A cos theta.
Ax is equal to a cos theta. Okay, so ax will be equal to a is 30 cos 40. Those having calculators, you can help us. So the x component of vector a is going to be 30 cos 40, which is going to be 22.898, which is just the same as 23 meters. So ay is going to be what? If I want to find the y component,
A sin theta.
a sine theta. So ay will be equal to a is 30 sine 40. So 30 sine 40 is going to be 19.28, which is the same as just 19.3 meters. Do you have questions on how to find the x and y components? Do you have questions on how to find the x and y components?
No.
Okay,
No.
so this is what I wanted you to know today. Next time we are going to conclude vectors, and then you'll be able to answer almost all the questions from the past papers and from the tutorial sheet. And I believe you managed to watch the video because we have the tutorial sheet. It is already solved, and I think I posted the day before yesterday. I posted the tutorial sheet. Okay, so for today we end here. At 20 hours we are having chemistry. See you there.